So when the king tides do occur, it's almost like a precursor to what we can expect every single day in the near term future. I mean, and that's projected to be over 30 days per year by 2050. So that's 3 to 6 times more frequent by 2050. The term king tide originated actually in Australia and then was taken up in North America. So these king tides are contributing to higher sea levels. It's not just on the East Coast, it's all on coastlines around the planet.
Hello, and welcome to another edition of the Climate Emergency Forum. I'm Herb Simmons, the author of A Climate Vocabulary of the Future, and I'll be your host today. As the seasons change, one of the characteristics of the fall, and sometimes the spring, along much of the United States East Coast and elsewhere, is the emergence of what are often called king tides at the seashore. These are very high tides that occur when the Earth, the sun, and particularly the moon are in alignment, strengthening the gravitational pull and resulting in abnormally high and sometimes dangerously high tidal behavior. King tides are worsening, like most everything else is, because of the additional heat, the sea level rise, and the moisture that global heating brings about. Some predictions project that the number of days that a community might experience a king tide could rise from a handful, 5 or 10 days now, to as much as 30 to 80 days a year in places like Norfolk, Virginia, Charleston, South Carolina, and near me in Annapolis, Maryland. These tides can, of course, be dangerous, damaging infrastructure, leading to more saltwater intrusion, and even requiring the evacuation of some areas, temporarily or permanently. We'll be examining this phenomenon today. Why is it occurring, what the consequences are, and what, if anything, we can do to better prepare for these king tides. And as always, now please stay tuned after the discussion as we'll conclude with a brief summary of some of the key climate stories that have emerged in recent days. So with that, I'm, as always, delighted and happy to introduce our regular panelists, Paul Beckwith. Paul, as you know, is a climate systems scientist who lives in Ottawa, has taught at universities in the region, has a YouTube channel with over 1,600 videos and millions of viewers, and who stays on top of most of everything. And so, Paul, give us your take on why are these tides called king, and what does that mean?
Well, the king tide phenomena is basically an enhanced tide. It can be as large as a foot to 4 feet above normal high tide, and it's the gravitational pull when the moon, sun, and Earth are in alignment. So they're in the news right now because they've been quite significantly, specifically on the U.S. East Coast, early to mid-October. They're also going to be just as large, probably between November 4th and November 9th, and then again between December 3rd and December 6th, according to NOAA. So king tides are becoming more predominant in the news because the water levels on many coastlines is significantly higher than it would normally have been or has been in the past. So king tides are just one component of the rising coastal sea levels on coastlines. So a number of factors that also contribute to higher water levels are, of course, king tides, highest tides of the year, 1 to 4 feet above normal. People often call it sunny day flooding. But heavy rains also add to those water levels. Onshore winds, when onshore winds are strong, they're pushing water from the ocean to coastlines, contributing to the high water levels, creating all kinds of things like rip currents on coastlines. Of course, sea level rise is a steady contributor to higher and higher overall water levels. Tropical storms like hurricanes, of course, they're associated with very high water levels, storm surges, even storms that don't reach the level of tropical storms or hurricanes are very important in pushing water towards the coastlines. And then the geometry of the coastlines, the geography is important. Water can get pushed up into bays, and those areas can have excessively high tides. Land subsidence is another key factor. The land actually sinking, whether it be from deposits of silt, for example, in the Gulf of Mexico, the silt from the Mississippi rivers pushing the land. New Orleans is one of the most famous places for ongoing land subsidence, which is significant. Coastal erosion, as coastal erosion occurs, the water can go further inland. If there's an ENSO, like a La Nina, El Nina, depending on that cycle, that can influence the water currents and the water levels. And I've already mentioned the coastal geometry is very, very important. So all of these factors play into it. So when the king tides do occur, it's almost like a precursor to what we can expect every single day in the near term future. I mean, Herb, you mentioned that there's been, coastal flooding from king tides, maybe 5 to 10 days a year along the East Coast and parts of the Gulf Coast, and that's projected to be over 30 days per year by 2050. So that's 3 to 6 times more frequent by 2050. The term king tide originated actually in Australia and then was taken up in North America. So these king tides are contributing to higher sea levels on a periodic basis, but it's not just on the East Coast. It's all on coastlines around the planet. Depends on latitude, depends on topography, and many other things. So we hear about the ones that are causing flooding of urban areas. Boston, for example, had very high king tides recently. Miami, different places all along the U.S. coast, from basically Corpus Christi up to Cape Cod. There was also the remnants of a storm, and we just had massive coastal flooding in Alaska. King tides aren't the direct contributor that's mentioned in the article, but it does add, and anything that incrementally adds to the sea level, can play a role. So the Alaska flooding was particularly a typhoon that hit Japan, crossed the Pacific Ocean, and still had high strength. Why? Because the sea surface temperature was very high. When sea surface temperature is very high, water expands and it creates local water levels and tidal heights that are all part of the equation. So we have to look at all of the factors causing it. And sea level rise, warmer ocean temperatures, marine heat waves is also another component. That's hopefully an overview. And, it's just when king tides occur, on top of everything else, we kind of notice because it floods basements and roads and things like that. A very important factor for increased sea level rise along the U.S. East Coast, and that's the slowing of the AMOC, the Atlantic Meridional Overturning Circulation. So what it means is as it slows, it goes closer over the continental shelves to the U.S., and that has a great impact on sea level rise. And if the AMOC significantly reduces from its present level, that alone could cause sea level rise up to a foot along a vast section of the U.S. East Coast and the Maritimes in Canada.
Of course, we have talked, and I'm sure we'll continue to talk about the AMOC, given its dire and almost sort of disaster movie consequences or potential consequences for not just Northern Europe, but as you point out, Paul, for the East Coast of Canada and the United States and throughout the planet, because everything is connected to everything else. It's one of the messages that we attempt to convey here is that every program we talk about, every subject, we only have 30, 35 minutes to talk about it, but there are connections with everything else. Is it fair to say that unlike so many of the extreme climate phenomena that are often so unpredictable and so intense that it's very difficult to anticipate or prepare or address them, king tides, at least so far, seem fairly predictable as to when they come because it's with a full or a new moon, I guess, at the time of the month and which months, and it's usually only a foot or two. And I say only, it may be still significant locally. So it seems to be, at least at this point, one of the more sort of predictable events that can be sort of prepared for intelligently and rationally by local governments, to at least to some degree. Is that reasonable?
Yes. I mean, it's one main factor. When there is a king tide, the risk of flooding is much greater, but it may require that you have a king tide plus strong onshore winds, for example. Sometimes the king tide alone is not enough. Well, on many coastlines, the king tide alone is not enough to cause flooding. Like often on the west coast of the US, it's just not enough to cause flooding. It's when you have these other factors plus the king tide that you can, be in trouble for many coastlines around the planet.
Thanks, Paul. And just a note, we're all used to using acronyms, myself guilty. When Paul said NOAA, he did not mean the NOAA that had the Ark, though that might be relevant to today's discussion, but rather the National Oceanic and Atmospheric Administration.
In a few days, there's going to be massive public protests around the U.S. No King's Day. So they're protesting king tides, actually. No, they're not. They're protesting another type of king, but it's kind of apt that we're getting king tides and there's a massive public protest for no King's Day.
Well, we'll see whether the power of protest can have any more impact against human beings than it may have against nature. Time will tell. With that, let me switch over to the west coast of Canada, where rumor is that king tides are not particularly prevalent, but who is prevalent is Dr. Peter Carter, who lives in British Columbia, is a retired medical doctor who is the founder and writes for the Climate Emergency Institute. He's been an IPCC expert reviewer. And I noticed, Peter, I believe, correct me if I'm wrong, that you've now had at least some of your coffee, so you're all set to go.
Yeah,
So the
yeah,
floor is yours.
yeah. The older you get, the better the coffee works, I think. So, Paul covered the king tide very, very comprehensively. I'll just throw in some information on sea level rise in generally. I'll start by saying that I've always thought the sea level rise is a very, very good climate change indicator. And that's because there's two reasons for sea level rise. One is the thermal expansion of the water, so that's direct. But the other, of course, is the melting of ice from glaciers on land and the ice sheets. So you've got two indicators here, fundamental indicators, which are reflected by sea level rise. So that's been my great interest. The cause of sea level rise, I just want to start by saying, is the cause of everything. It is fossil fuel industries, emissions, livestock industries, fossil fuel corporations, banks, and governments. That is the cause of all this. So I always like to go back to the first assessment of the IPCC in 1990. And this one's quite amazing. They had, of course, sea level rise. They predicted in 1990 that sea level rise will accelerate. That's quite amazing, right? They also said if you stop emissions, sea level rise won't stop. So they were really on it. And the other thing that they had is they had a commitment to sea level rise. So that's really, really very progressive. We go back to 1990. Okay, up to date. So NASA reported that global sea level rise in 2024 rose faster than expected. Everything's coming earlier and faster than expected, I guess. The expected sea level rise, there's a lot of numbers, but the expected sea level rise is about 5 meters. Now, if all the ice sheet melts, it's going to be 8 meters, but we're talking about thousands of years. Now, no matter what, today, sea level rise is going to keep increasing at an accelerating rate, and that is going to last for 1,000 years. Even with our best interventions, sea level rise is going to continue to rise for hundreds of years. And so we have what Paul's already mentioned, of course. We have rapidly increasing and accelerating displacement of coastal, lowland, and island communities with this huge migration, huge waves of migration, many, many, many millions of people. The longer emissions continue, the more sea level rise is committed, and that applies to all future generations. On the direct causes, so about a third of the sea level rise is ocean thermal expansion. And then now the rest is land glaciers and ice sheets. The land glaciers actually, they significantly, substantially contribute to sea level rise. I'll go back in time again, which I can remember very well. In 1992, the United Nations Climate Change Convention stipulated that small islands and low-lying countries which were specified, they had a list of all the most vulnerable countries and regions. They had to be protected from dangerous climate change. And of course, we've done just the opposite. This is very much part of the unprecedented crime of continuing to emit greenhouse gases, and not to mention denying that. Recently, recent research, the accelerating rate of sea level rise has doubled in the past 3 decades. Absolutely incredible. The same paper actually extrapolated what was going to happen in the next few decades, and it will reach a high level of a scenario. It will reach an upper scenario, a worse scenario. There was a very important paper published, which was that polar ice sheets are vulnerable at 1.5 degrees C. And so, therefore, sea level rise is going to increase rapidly its acceleration. The IPCC assessment says there is no scenario that stops sea level rise in this century. There's not a whole lot of difference between the scenarios, actually. Millions and millions and millions of people are going to be forced from their communities, from their homes. That's going to happen. Paul already mentioned, of course, the most important, saltwater incursion on these regions. That's going to damage the agriculture in these regions. Of course, Bangladesh, the people are already being forced to abandon agriculture in the most vulnerable regions there. It will also have an effect on biodiversity because we've got a biodiversity emergency. So fish, birds, wildlife, the coasts and the low-lying coasts are very, very high biodiversity regions. So I'll stop with that.
As you so often do, you present information that is sobering. In fact, sobering may be an understatement, but I think it's important to emphasize, as distressing as it may be, if particularly for those who may be hearing it the first time, that even if and when the world reaches so-called net zero and decarbonizes, that will not stop the inexorable rise of sea level rise because we will have reached net zero at temperatures much higher than we have today. So if sea level rise is occurring at 1.4 or 1.5, wherever we are, and has been at much lower increases in temperature, it's certainly not going to become less prevalent if we reach net zero at 2.2 or 2.8 or 3.2. We have to be prepared for the longest of long runs, something that the human species is not particularly adapted well to. So with that, let me turn it back to Paul. And King Tide and no kings or anything else you'd like to add to what Peter has said?
Yeah, so I mentioned about 10 different things that are all contributing to this coastal flooding. King tides are kind of, they bring it all to the forefront because we know they're going to happen. And when you sum up all the other contributing factors and you get severe coastal flooding. In fact, the annual frequency of high tide flooding is about double what it was just back in 2000. Of course, climate change is the underlying factor for a lot of global sea level rise, but there's also a lot of different local effects. So, you might think that sea level is like the same everywhere on the planet, but it's very, very different. For example, if you have an underwater mountain, the sea level is much higher over that mountain because the mass of that underwater mountain is gravitationally pulling water towards it. We all know that the melting of the ice caps on Greenland and Antarctica are causing sea level. A lot of that, of course, is, we just think of the direct water added to the ocean increases sea level. But there's another huge factor, and that is, when you've got a large mass of ice sitting on Greenland, that mass of ice is attracting water. So water is kind of pulled towards Greenland. So as the ice cap decreases in mass, not only is water directly added to the ocean, but the pull of other water is decreased, so that water sloshes to lower latitudes, increasing sea level rise even more then. So there's all of these different effects. And also, the reduction of ice on Greenland means that there's less weight pushing the land down, so there's isostatic rebound, the land rises up. And that also pushes water away from Greenland. The exact same thing I'm describing in Greenland is happening in Antarctica. So there's some coastlines where the apparent sea level is dropping because of this massive isostatic rebound. But that's a bad thing for other places on the planet, especially places that are subsiding. And I've mentioned New Orleans and some of these other places where there's subsidence. So all of these factors are contributing. We fortunately have very accurate sensors on like GRACE instrumentation on a constellation of satellites, gravity anomaly satellites that can actually measure accurately what the present sea level is around the planet. And then, as long as these satellites are in operation and functioning, which is hopefully for a long time, but I guess everything today is uncertain depending on who is running the satellites, that's giving us an accurate picture over time of what sea level is doing. So, what we're seeing happening, say, 5 to 10 days a year now, imagine not only are we increasing from expecting that to increase to 30 days plus, but it will become a permanent thing on many coastlines. So the idea that the coast is toast is becoming a more and more real thing to many people. So obviously, it means that many coastal properties will be uninsurable, and it will cause huge demographic shifts. And just look at the demographics. Many, many people live along coastlines around the globe today, and those people are all going to be affected, in an enormous way by increased sea level.
I can hear the chants now. The coast is toast. The coast is, or the toast is coast. One or the other. Not a happy cheer. Peter, if you were working in a local government or in a civic group along the coast, what can communities practically do to minimize the impact of king tides, as we've talked about going from a handful a year to two or three or six handfuls a year in the coming decades? You both emphasized that this is largely inexorable, that it's, only tangentially related to how fast we reduce emissions, and that we've reached a kind of, even though it's not maybe technically the case, but, kind of a sea level rise tipping point, if you will. So, do we just, shrug our shoulders and say, let's get the hell out? Or are there practical steps that communities can and should take?
Number one, and this is what we're trying to do on this emergency forum, is that people should be aware of their particular local and regional vulnerabilities. And nowhere does that apply more than to coastal regions and, of course, low-lying islands. So really, those people, it's in their absolute best interest to be lobbying their governments to actually do something to put emissions into decline, because emissions are still increasing. And as I mentioned, actually, two recent papers stated that we have to at least slow down this acceleration of sea level rise. And there's only one way to do that, and that is to cut emissions immediately. So I was very happy that they mentioned that. And of course, nothing demands more adaptation than sea level rise. There are certainly things that people can do. They can work to protect their coastal wetlands and mangrove regions and places like. Oh, that reminds me. One effect of sea level rise, particularly on these regions, that I didn't mention, is that it reduces the carbon sink. This will reduce the carbon sink because there's a significant amount of carbon in particular countries that is absorbed, of course, by the plant growth, etc. So that's important. To adapt to sea level rise, and there's a couple of cities that are already doing it in the States, is a massive undertaking. It must be done because, as we've said, sea level rise is inexorable. Not only that, it will continue increasing. So All the governments of the world, and I repeat this then, what I say often, must get together, must cooperate, because a huge amount of funding is required for massive redevelopments, adaptation developments, for the coastal cities to be able to operate. So that's absolutely essential. As Paul's mentioned, of course, this applies to the United States of America. The United States maybe used to think that it was relatively invulnerable to climate change and its impacts, but it's most certainly not. EPA, Environmental Protection Agency, which is now pretty well, I think, being trashed by the present Republican administration, they had a really excellent section on sea level rise in the states and reasons, cause, effects. The projection for the United States is that by 2030, the frequency of the high tide type flooding will be 2 to 3 times more than it is now, and it will continue to increase at that rate. So there's a huge, huge difference. And as Paul's mentioned, the flooding is going to it is become more frequent along much of the U.S. East coastline. This has been measured, right? I mean, it's been measured accurately, indisputably, since the 1950s, and it was certainly, as I say, recorded very well, and even predicted in the first 1990 assessment. So we've all mentioned this most important aspect of sea level rise, and that is the salinification of agriculture, the damage to agriculture. Now, I did find one paper that has covered this very, very well. What that finds is the amount of cropland which is vulnerable to that impact of sea level rise is 336,000 square miles, over 300,000 square miles. They have a really interesting map of the projections that they did. It looked to me like Europe was the worst affected, really, although in an extent, the east coast of India is way the worst, according to this research, which is very interesting and important.
At least all that water running from the ocean onto the land, it will reduce the overall vertical height change of sea level, right? You have to add more and more water to the ocean when the ocean's a much larger area to get a particular rise of sea level. So it's an interesting factor. We talk about like a meter of sea level rise. I wonder if all those calculations are assuming the existing coastline or whether they're assuming the new coastlines as the water impinges on the land. I think it's an important question, and I don't think the models all account for that properly.
Yeah, you're so right in that generally, Paul. I mean, so many aspects are not captured, as they say, by the models. So we really have to bear in mind that the models are models and
Yeah.
they're under predicting.
Just real quickly, a couple, you both mentioned the saltwater intrusion. Well, that's an enormous problem all over the world in estuaries and coastlines where it's destroying agricultural productivity. So every time there's a king tide and every time sea level rise increases, you have what are called ghost forests in low-lying areas where the underground soils and water are too saline, too brackish to support life. And so that in turn harms farming and food. Everything is connected to everything. We only take a slice. We try to go deep into that slice every week, as we've done today. So I want to thank Paul and Peter, as always, for giving us your perspectives on what will be a continuing inexorable problem of sea rise, of king tides, and of the increasing acceleration of the climate crisis. And with that, just a couple of recent events in the climate world. Number one, I think one of the big headlines that many of you have seen is that there are a group of researchers in Exeter in the UK and around the world who monitor and have been for years climate tipping points. That is, major changes in climate systems, whether it be the AMOC, as we talked about, or the Amazon, or the Greenland ice sheets or the Antarctic ice sheets. I had the privilege of attending their conference in Exeter in the summer, and the report was issued a couple days ago. the headline it made around the world, not that it surprised those who watch the Climate Emergency Forum, is that they basically have more or less pronounced coral reefs as the first activated climate tipping point. And as we've talked here in programs on coral reefs, and I'm sure we'll be speaking in the future, coral reefs are perhaps the most productive and rich areas on the planet. They're just cover a tiny portion of the planet's surface, but they're the keystone, if you will, of keeping the oceans alive and the welfare and well-being of tens of millions of people. What they concluded was that once you reached a threshold of over 1.2 degrees C over pre-industrial, and we're now 1.5, 1.4, depending upon the month, coral reefs, by and large, with some exceptions, are dying off and are unlikely to make a robust recovery. This is an enormous loss to all of us economically, oceanographically, and emotionally, as we as human beings have intentionally, because we've known about this. I think Peter, I see Peter, you're nodding. I mean, we've known about this. This is not some surprise that, oh my goodness, we never knew this was going to happen. We've known about this, the we, for decades, and we've chosen to act in the most half-hearted way and to mix our metaphors. The coral reef roosters are coming home. Sorry for that. But anyway, that's the main thing I wanted to address. In fact, I feel so strongly about it that I'd like to literally take just 10 or 15 seconds of silence. Let us pause and think about coral reefs and what we have lost and what the world is lost or is losing. Take a deep breath. And I would encourage you, as I know Peter and Paul always do, not lose hope, not lose faith, redouble your activism, donate to your climate groups, demand your governments act, work with your local governing bodies, if they're on the coast or the mountains or the desert, wherever they may be, to take steps to minimize loss and damage and reduce emissions, because what we do collectively still will make a difference, a big difference. One or two other quick things. Paul mentioned the Alaskan disaster or the typhoon, but sort of further south in Mexico, there was a massive storm. 100,000 people had to leave their homes. That's 100,000 people, and probably none of us have heard of it, or very few. It's just another day in the climate world. And in a sort of tiny little announcement that amused me in a way, not that there's anything inherently funny about it, there was an announcement that two countries, China, of course, the country with the largest population and the largest emissions and the biggest footprint on the planet, reached an agreement to reduce emissions and cooperate with Iceland, one of the very smallest countries in the world, with a population of 3,500 people in China for every one in Iceland. It's an example of what I call in my book climatelateralism, where two countries work together to support each other, no matter how large or how strong that might be. The last thing I want to say is the contrast that we see, at least to me, are truly hard to absorb. So at the same time that the United States government has canceled pretty much the largest solar project planned in the United States at this time, the UK they approved their largest solar project of 1,200 hectares that will be able to power 300,000 homes. So we've got a world problem, and yet each country takes its own pathway. Some go up, some go down, some do nothing, and this is the world we live in. So with that, as always, again, thanks so much, Paul. Thanks so much, Peter, for giving us your perspective on king tides, what they mean, and what the future and the consequences and the prognosis is. And with that, as always, I'd like you and encourage you to like our channel, to subscribe to our channel, to go to our website, climateemergencyforum.org, look at the articles, look at the archives, and don't forget to look at, of course, the donate button while you're there. Talk to your friends and family about our program. Forward this link to them. Please, please come back next week, as always, when we will have another edition of the Climate Emergency Forum. Thank you so much.